All right, this is a video lesson for Unit 7, Lesson 2, which is solving linear inequalities. Now, solving linear inequalities is just like solving an equation. There's one big difference, and we're not even going to talk about this big difference right away. We're going to wait, because I want you to see how much this has in common with solving equations. Okay, so the first problem we're going to do is x minus 4 is less than 8. What I want you to realize, and I'll just write this off to the side, is that this is just like the problem x minus 4 equals 8. In that problem, which we did a long time ago, we would add 4 to both sides to get that negative 4 out of there, and we would have x equals 12. Well, it's going to be really, really similar now. Okay, what I like to do at the start of one of these problems is draw what I call the river. Just separate the two sides of the inequality. And I am going to get rid of this minus 4, just like I did in the equation, by adding 4 to both sides. And now I have x, and I have 12. Okay? And instead of x equals 12, we know it's x is less than 12. We're just going to carry down the symbol from up above. And that's our answer. X is less than 12. Now, with inequalities, we don't just like to write out an answer. We like to show it on a graph, because there's actually lots of answers. Anything less than 12 works. So 11, 10, 9, 8, 1.3, anything that's less than 12. So that less than symbol is going to lead us to an open dot, and the arrow's pointing to the left, so we're going to shade to the left. And there's our answer. Simple as that. Let's do the same problem over here, but this time what's separating the variable from what it's with is multiplication. It's 2 times x. Okay, and we want to get rid of that 2, so we're going to divide by 2. I draw my river. If I want to get rid of that on one side, I got to do it on both sides. So I divide by 2. That makes it x. 20 divided by 2 is 10, and it's going to stay a less than or equal to sign. So x is less than or equal to 10. I put the 10. It's going to be a closed dot this time, and it's still less than for this problem, so we're going to shade to the left again. And there's our answer. Now, let's get into when it's tricky, when it's different. Okay? There is one situation we really have to watch out for, and that's when we are multiplying or dividing by a negative. That word is actually really important, the by word there, and you'll see why in a little bit. Okay, so here's a problem that I want to do, and I really want to do it just to be able to explain this to you. Okay, I'm going to do it fast, and I'm going to do it slow, and we're going to talk about the difference between the two. Okay, so really quick on this problem, negative 2x is greater than 12. I'm going to divide both sides by that negative 2 to get rid of that negative 2. I do it to both sides, so divide by negative 2. X is alone, and on the other side you have negative 6. It was a greater than from the beginning, so it's still a greater than, and we have x is greater than negative 6. Okay, there's our answer. Now, we're going to do it slow. Okay, I am going to do something weird here. I'm going to move over that negative 2x to the right side. So I'm going to add 2x. Bear with me. It's a legal move, okay, to move the 2x. So I'm going to have 0 is greater than 12 plus 2x. Now I'm going to get rid of that 12 by subtracting by 12. This is just it's a weird move that we're doing, but just watch. Okay, I'm going to subtract 12 from both sides. Okay, so I'm going to get negative 12 is greater than positive 2x. And then I'm going to divide both sides by 2. And I'm going to get x, still have that greater in the middle, and I have negative 6. So I have negative 6 is greater than x. Which actually, we're going to talk about this more at the end, but that's actually, written backwards. You have the x on the wrong side. So we could flip the whole thing over. If negative 6 is greater than x, that means x is less than negative 6. Now think about this. These two problems were the same. This and this, that's the exact same problem. Look at our answers. Our answers are different. One says greater than, one says less than. Believe it or not, the problem that's wrong here is the fast and easy way. That's wrong. There's actually a little sneaky trick that we didn't do. There's something that we missed here that which actually made our first problem-solving method illegal. And it only happens when you're multiplying or dividing by a negative. Okay? Now, this method over here is way too long. So what we need is we need a way to do it fast, but correctly. And that's what we're going to talk about here in the next part. Okay? So the special case that we have to pay attention to is when we multiply or divide by a negative. This is probably the most important note of the entire unit right here. When you multiply or divide by a negative, you have to flip the inequality sign. Okay? Had I done that in this last problem, had I flipped this greater than, I'd be right, because we learned right here that the answer is supposed to be x is less than. We said greater than. Okay? And that's all you have to do to save yourself all of this work up here, is to just flip the inequality sign. So here's an example where we're actually going to multiply. I'm going to multiply both sides by negative 15 to get rid of that negative 15. I do it to one side, I do it to the other side. Okay? So x is alone over here. This becomes negative 150. That's what 10 times negative 15 is. And I just multiplied by a negative. And whenever you do that, you have to flip the inequality. So it went from a greater than to a less than. And that's it. Now we can do it fast, but it's also correct. Okay, so we put negative 150 on the number line. We draw a closed dot there, and we're going to shade to the left because it's a less than. And that's our answer. So that's the new trick that you have to know. When you multiply or divide by a negative, you have to flip the sign. So now here's another problem. You might want to try this, pause the video and try it, and see if you're doing it right, because I bet a lot of you are going to make a little mistake here. Okay, for this problem, I have 3 times x is less than negative 9. I'm going to divide both sides by 3. It's going to become x is, well, we'll find out, compared to negative 3. Okay, what a lot of you are going to want to do is flip the sign here. Okay, but it actually stays less than or equal to. And the reason is I didn't divide by a negative. 3 is not negative. So I can divide by a positive and leave the sign the same. Yes, I know this negative 9 is negative, but that's not what we were dividing by. In this problem, the thing we were multiplying by was negative. That's why we had to flip the sign. In this problem, the thing we're dividing by is positive, so we don't have to flip the sign. Gives us an answer of x is less than or equal to negative 3. So I go to negative 3, close dot, shade to the left. We had a lot of shade to the left so far in this lesson. And that's our answer. I would encourage you to try these problems and then check the video afterwards. But I'm going to go slow here, so if you need it, you can watch me slowly go through this. But whether you're good or bad at these problems is really going to be determined by how you did with equations. If you struggled with equations, you're going to struggle with this, and it's something we need to fix. If you were good with equations, you'll probably find these next 3 problems not too hard. Okay, so what I'm going to do is I'm going to start off by separating my equation or inequality into 2 halves. I'm going to try to get this x alone, which I need to get rid of addition and subtraction first. So I'm going to subtract 3 from both sides. It's going to give me 2x is greater than or equal to negative 16. When I'm adding or subtracting, I don't have to worry about flipping the sign because there's no rule about what happens if you add or subtract. It's only when you multiply or divide that something special happens. Now I'm dividing, so I want to be careful. I divide by 2, that's a positive. Okay, so I'm going to be able to keep my inequality as a greater than, and it's x is greater than or equal to negative 8. That's my answer. X is greater than or equal to negative 8. So I go to negative 8. It's a greater than or equal to, so it's going to be a closed dot. And I'm going to shade to the right because it points to the right. Finally got a greater than there. All right. On to number 6. Remember that you need to clean up both sides, simplify both sides of an equation or an inequality before you can solve it. So I'm going to have 2z plus 10 is greater than or equal to 7z plus 7. I have to distribute that. 7z plus 7. Got to distribute those, that 7. Now, I need to get the variable to one side. You might be thinking to move the 2 over to keep the z positive. I would prefer you to move everything, or all the variables to the left so that you can simply, so you can graph easier. Okay, so I'm going to subtract the 7z from both sides. That's going to give me negative 5z plus 10 is greater than or equal to 7. Then I'm going to subtract the 10 to start getting my negative 5z alone. And I'm going to get negative 5z greater than or equal to negative 3 when I subtract that 10 from 7. Now I'm going to divide both sides by a negative. Okay, whoops, sorry, negative 5. Dividing by a negative means we're going to flip the sign. So this is all alone, z. Now we have a flipped sign less than or equal to. Negative divided by negative is a positive 3/5. And there we go. Now you might be freaking out, oh, I got decimals or fractions here. Well, that's not hard to graph. Just put a 3/5 here. 3/5. And then we're going to have a closed dot because it's a or equal to, and we're going to shade to the left. And there we go. One more here on this level, and that is going to be one that has some decimals. Okay, don't freak out about decimals. Just use a calculator. Again, I want to get my variable to the left, so I'm going to add 7x to both sides to move that variable over to the left. So I'm going to have 10x plus 1.2 is less than negative 1.3. I want to get rid of that 1.2, so I'm going to subtract 1.2. That's going to give me 10x is less than, if you have to use a calculator here, use it. The answer is going to be negative 2.5. Then I'm going to divide by 10. With decimals, I don't really want decimals within fractions, so I'm just going to take this answer as a decimal. Okay, notice I didn't divide by a negative, so I can keep that as a less than. And I'm going to go to my calculator and do negative 2.5 divided by negative 10, or sorry, positive 10. And that's going to give me an answer of negative 0.25. And there's our solution. I go to my graph, negative 0.25, open dot, shade to the left. It's open because it wasn't or equal to, and we shaded to the left because the arrow pointed to the left. Now, something I want to talk about really quick with just a couple of examples is what to do when the variable is on the right. And we're going to do something really simple that we already did earlier in this video, and that's just flip the inequality. If the variable's on the right and I want it on the left, I'm just going to flip it. So I'm going to go and say x and 5 instead of 5 and x. And if I flip it, I have to flip everything, including the sign. So I flipped the x and the 5, and I'm going to flip the sign from a less than to a greater than. So x is greater than 5. And we know how to graph that. We put a 5 on here with an open dot, and we shade to the right. So if x is ever on the right, I just change the inequality to get x back on the left, and then I graph that. Okay? Now on this problem, I'm going to solve it. So add 4, add 4. It wouldn't really make sense to move the variable over. Okay, so I'm going to add 4, and get 7 is greater than or equal to x. And then, again, I'm going to do the same thing. Oh, I don't like the order here because x is on the right, so I'm just going to put x on the left, move the number over to the other side, and then flip the inequality sign to be a less than or equal to 7. And then that's what I'll graph. So I'll go 7, close dot, to the left. And we're going to end this lesson now with a couple of quick word problems. Okay? Now, don't tune out at this point because these word problems do show up on the test. Okay? Casey has been mowing lawns to save up money for a concert. He earns $15 per hour and needs at least $90 to go to the concert. How many hours should he mow? Okay? So, we are going to start off with this. Our variable is going to, the thing we don't know is the number of hours. So x is going to represent the number of hours. Okay, the inequality. Well, we want his money to be more than 90. Okay, if it's 90, we're good, and anything more than 90 is good. So I want his, and I'm just going to do this for now. You don't have to write this. His money, we want that to be greater than or equal to 90. If his money is bigger than 90, he's going to have enough of it. Okay, because that's how much money he needs to save. Now, what is his money? Well, his money is he has $15 per hour, so that's going to be 15 times the number of hours, 15x. So we want 15x to be greater than or equal to 90, and then he'll have enough money to go to the concert. Now that's something that we can solve. We're going to go and draw our line and divide by 15 and divide by 15, and I go to my calculator if I have to. 90 divided by 15 is 6, so x is greater than or equal to 6. That's our solution. I go to the graph, I'm going to put a dot at 6, and I'm going to shade to the right. And in a sentence, as long as Casey works 6 or more hours, he's going to have enough money for the concert. Casey should work at least 6 hours. As long as he does that, he'll have enough money. One final word problem, and then we're done. Okay. Cool Tees charges $25 to make a shirt. $25 just to start the process. It's called a screening fee. And then $5 per shirt. Another company, T-Shirts R Us, charges $15 to make the shirt, so screening fee. And then another $6.50 per shirt. They ask us, when is Cool Tees cheaper than T-Shirts R Us? Well, first of all, the thing that changes is the number of shirts. So X is going to represent the number of shirts. The inequality, we want Cool Tees. I'm going to do this again and we'll erase it. I want Cool Tees cost to be cheaper. That means less than. Not equal to. That wouldn't be cheaper. That'd be the same. So less than our Us cost. Okay, well, we actually have to put variables and everything in there. So Cool Tees, they charge $25 and $5 per shirt. So I would write that as $5 per shirt, 5x, plus the $25 to start. T-Shirts R Us, they charge $15 and $6.50 per shirt. $6.50x plus the $15. So I took Cool Tees cost, which we've done this kind of problem in the past. I took Cool Tees cost and I set it less than, not equal to, less than T-Shirts R Us's cost. And now I'm just going to solve this. Okay, so what I'm going to do is I'm going to try to get the variable to one side. So I'm going to subtract 6.5x from both sides. Don't be a hero here. You can use a calculator if you need to. 5 minus 6.5 is negative 1.5x plus 25 still. And on the other side, I've got 15. I didn't multiply or divide by a negative, so it stays less than. Now I want to get rid of that 25, so I subtract 25 from both sides. Okay, that's going to be negative 1.5x is less than negative 10. And then I'm going to divide both sides by a negative. So if you divide by a negative, that means you have to flip the inequality. So this is going to become x is greater than negative 10 divided by negative 1.5, which my calculator tells me is 6.7. So x, the number of shirts, has to be more than 6.7. Well, you can't really sell 6 2/3 of shirt. So really, in reality, this would be that we need to sell 7 or more shirts. So we could word it that way if we want. Okay, the number of shirts sold needs to be greater than 6.7, or you could say cool tees is cheaper if you order more than 6.7 shirts. So you could say 7 or more shirts. You could say more than 6 shirts, or you could say more than 6.7. That's probably the easiest way to say it. And that's the end of this lesson. So there's a lot to unpack there, but hopefully you understood it pretty well.